Good afternoon. This presentation is going to show a lot of code in the slides, so you want to be sure that you have a good view of the screens from wherever you're sitting. I'll give you 30 seconds if you want to move up closer. Well, those of you who are moving up, how many people were unable to attend the previous presentation in this room by Omri Gazit on ADO overview? Okay, great. So I'm going to start off with a little bit of a recap of what Omri presented this morning as far as the ADO side goes. And the XML stuff you'll be able to get from Chris Levitt or William Adams' presentations. My name is Mike Pizzo, and I'm a senior program manager in the web data group at Microsoft. As Omri said in the previous presentation, I've been at Microsoft a little over 13 years, the last 10 of which have been involved in defining how you work with and access data within the Windows environment. So, as Omri said, if you've got a problem with it, it's probably my fault. I was one of the principal designers of ODBC, along with Kyle Geiger and others, and a member of the ANSI and ISO standards committees that progressed ODBC as an international call-level interface standard extension to the ANSI and ISO SQL 92 specifications. Following ODBC, I became involved with OLADB, which was a COM-based componentized architecture for working with all types of data. OLADB, together with ADO, make up our universal data access strategy. I was first introduced to this .NET platform a little over 2 years ago at an architectural offsite. And of course, my first thought was, what does data mean in this new platform? Having at the time recently spoken, perhaps to many of you, at the PDC and TechEd conferences that year, foremost on my mind was my own personal safety, realizing that I would be presenting to you today about what data looked like in this .NET framework and needed to make sure that it was a logical evolution of the universal data access story that I had just gotten done telling you you should be pursuing. At the same time, there are a number of opportunities in this .NET framework, as well as a number of innovations that went on after the design of ADO and OLADB, such as the emergence and grand acceptance of XML, that we really wanted to take into account in defining an integrated data access architecture for the .NET platform. So while it's possible to interact with existing ADO and OLADB code through COM interop, ADO Plus provides a much more robust and tightly integrated data architecture for new code being written within this .NET framework. This afternoon, Tom and I are going to go through the object model of ADO Plus and show you some code that demonstrates how you use ADO Plus within this .NET environment. And I sincerely hope you like what we have to show you today. As I said, I'm going to start off a brief recap of the ADO Plus architecture and go quickly into the ADO Plus object model. Once we've gone through the basic object model, we're going to talk a little bit about data binding and then have examples for using ADO Plus with XML, sets and web services, and then something called strongly typed data sets. But first, an overview of data in the web platform. Sort of the starting point, the place I want to start, is something called the managed provider. The managed provider is the equivalent of an OLADB provider in the native world. It has a connection and command object that look a lot like the connection and command objects you have today in ADO. And it has something called a data reader, which is conceptually similar to a forward-only record set. The managed provider is the object or the set of objects that you use for connected access to a data source. One of the major innovations in this new .NET platform is something called the data set. We'll go into the data set in a great deal of detail, but conceptually it is a set of related tables that you can work with in a completely disconnected fashion. The fact that the data set is by definition disconnected means that it has no knowledge of the data that it's accessing. It gives you consistent behavior, functionality, and performance characteristics regardless of the data which it contains. The data set is the target for the controls, designers, code gen classes, and the other things that you've seen demoed so far today as part of the .NET framework. There is an object called the dataset command, which is part of the managed provider. The dataset command is the object that interfaces between the command, connection, and data stream provided by the managed provider and the dataset. So on the left-hand side, you see a collection of objects which together represent really a superset of what you have today with ADO 2.6 in the native world. On the right-hand side, I want to draw a similar picture for XML. We start out with the XML reader, which is a pull model, parse level interface over XML. This is something that we've not traditionally exposed on the native side, and it is conceptually similar in scope to the pull level data reader over your data sources. Similar to the dataset, the XML document represents a cache for XML data. It is a W3C compliant DOM. And on top of that is built things like XSLT, XPath, validation, and the data navigator that Omri talked about previously, and Chris will talk about on Friday. We don't stop here, though. One of the major innovations of this .NET platform is the integration between the XML document cache and the dataset relational cache, in that we're able to synchronize these in such a manner as to give you both a relational and XML view over the same data. And we'll talk about that later in the presentation. This is just sort of a roadmap to the overall architecture. I'm going to start by talking about managed providers. As I said previously, managed providers manage the interaction to a particular data source. That data source is commonly a relational database, but it may be a file that you have on your system. It may be some very simple piece of code that is able to expose data. It is the managed equivalent of OLEDB. However, one of the benefits that this net platform gives us is the ability to get rid of the dichotomy we have in the native world between your high-level automation interfaces and low-level performant COM interfaces. So the same interface exposed to the user, the connection, command object, data reader objects that we'll be talking about in just a second, are those objects that the provider itself natively exposes. Microsoft will provide implementations of 3 different managed providers. The first is what we call the ADO managed provider, and this is, although the name is ADO, it is implemented directly on top of OLEDB. So you have a familiar programming model if you're an ADO programmer, and you're able to leverage immediately all of the OLEDB and thus ODBC data that you have today in your enterprise. The second Microsoft implementation of a managed provider is SQL Server Managed Provider. In fact, we will have 2 implementations of SQL Server Managed Providers. The first will be built over TDS and is a native TDS reader, so it reads directly off of the wire. The second is the implementation of the managed provider interfaces directly within SQL Server. And Jose Blakely will be discussing that more later in the conference. The third managed provider we have is a managed provider over Exchange data. Again, this is a native provider to Exchange that works over the DAV protocol. Managed providers have a generic ADO plus object model. And that ADO plus object model should look very familiar to all of the ADO programmers out there. It starts off with similar connection, command, parameter objects that look and feel and work the same way as the connection, command, and parameter objects that you're used to using today. One of the things that we've done where we've deviated a little bit from the ADO model is we've separated the concept of working with data in a connected fashion from working with a cached set of data. What we found when we started looking at how our customers were using data, and in a series of customer visits that we did a year and a half ago with a number of .com and financial industry companies, is we realized that there really were two different uses of the record set. One was when people were directly connected to the database and they wanted the fastest possible way to read the data from the database to free up that connection and get on with their life. And that was a forward-only use of the record set. The second way people typically used record sets was as a remoting object, a way that they could either data from the database or frequently with data that they created in their application, move data throughout the various tiers of their application. The fact that we had the same object model for these two different purposes turned out to be more confusing and more of a compromise for each of those models than what you could get if you defined two separate object models. So the data reader encapsulates the functionality of a forward-only, read-only record set. As we'll see, it looks very much like a record set in the way that you use it and work with it, with the one exception being it is a forward-only model. The second object we've already talked about a little bit, and that's the data set. And the data set is, by definition, a disconnected cache of data. By knowing the data set is disconnected, there are many things that we can do in order to provide you a much more familiar programming model using that data and to optimize how that data is accessed and moved throughout the tiers of the internet. Finally, there's a dataset command. As I said before, the dataset command is the object that is able to connect a dataset to some source of data. We'll now go through each of these objects in a little bit more detail, starting with the connection object. The connection object is fairly straightforward and represents the connection to the data source. Given that connection, you can customize the connection string, if you will, the username and password and credentials and the server that you want to use when you establish your connection. Once you're connected, you can control transactions. You can do begin and commit and roll back the particular transactions that you're using when accessing that database. The connection gives ultimate control over the state that you're maintaining at the database. So if you open a connection, start a transaction, and execute a query, you can hold locks on the records you're reading if that's what you want to do. If that's not what you want to do, you cannot start a transaction and be in auto-commit mode, or you can commit or abort that transaction or even close the connection as soon as you're done using it. Connection object is equivalent to the ADODB connection object that you have in the native world today. This slide, as well as the next couple slides, were actually taken from a tech ed presentation that I did in 1998 right here in Orlando. I found on one of my old laptop machines that barely runs anymore, it's been 2 years after all, an old presentation that I did, and it went through the objects defined within ADO. And so I took those same examples, and with a few tweaks, did the same examples that I'm presenting today for how the objects in AD Plus works. The first of these is the connection object. So, as with any other object within my .NET environment, if I want to make coding it simple, I'm going to start off by using a using clause specifying using system.data.ado. That's a way of explicitly defining the namespace that I want to use, so I don't have to qualify every time I use an ADO connection with system.data.ado.ado connection. Once I specify that namespace, in the next line, I simply knew an ADO connection, just like I knew an ADO-DB connection. Once I have that connection, I can set its connection string to a connection string, excuse me, much as I do in ADO-DB. In fact, the ADO connection is the implementation of a connection object on top of OLADB, so I can pass exactly the same connection string to this ADO connection object that I would have passed to the ADO-DB connection object. And once I've passed that string, I merely call open on the connection object, again, exactly as I do in ADO-DB. Now, we've not stopped with what the connection looked like in ADO-DB. There are actually some additional things that I can do here. For instance, since the .NET framework gives me constructor overloading, I can pass the connection string to the ADO connection constructor and save myself a line of code. But I wanted to demonstrate how the same code that I wrote before continues to work in ADO+. The next object is the command object. And the command object, not surprisingly, represents the command to be executed by the data source. Now, this command is not necessarily SQL. The command is whatever the data source that has implemented this command object expects it to be. With that ADO command, you can define a statement to be executed on the server. That may be a DDL statement, it may be a create table, it may be some database administration statement, or it may be a select command that queries the database and returns results. The command also has a parameters collection, which allows you to specify information that will be plugged into perhaps a prepared statement when you call execution. Finally, by calling execute on the command, you get back a data reader that you can use to retrieve results generated by that query. The command object, this should be no surprise, corresponds to the ADO-DB command object, and as I said before, may contain parameters that are used when executing the statement. Again, here is code that should be very, very familiar to any native ADO programmer. At this point, you're thinking, why did I even come to this? I already know ADO. This is using an ADO command. And again, I'm going to construct a new ADO command. I'm going to set its active connection to the connection I created in the previous example. I'm going to set its command text property to the query that I want to execute. This query happens to contain a parameter. So I'm going to add a parameter to man's parameter collection, specifying its name and type. And then I'm going to set the value for that parameter to the string CA in order to look up all of the authors within California. This is the reason you want to be here today, is because the data reader represents an improvement over retrieving streamed results from a data source. The data reader provides a forward-only, read-only stream over the results of an executed query. The data reader is conceptually equivalent to a forward-only record set. It doesn't support scrolling, and it doesn't support updating of the data that you've retrieved. It's suitable for cases where you are just taking the results and reading through them one at a time. That means that those results don't have to be cached in memory. They can be read and discarded immediately. It's suitable for things like generating output or summing up value within a particular field. The fields exposed by the data reader are typically accessed through strongly typed accessors accessed by ordinal. This is in contrast to how you access data using a record set today. Using record set today, there's something called a fields collection, and generally code that you write will look up a value within the fields collection by name. The problem with doing that is the creation of the fields collection creates objects, and those objects have to be garbage collected. Also, the string lookup, in order to find the column within that row, is expensive. So by extending the record set model and providing type-specific ordinal lookup mechanisms for the fields of the row, we can provide much better efficiency in retrieving the data on a column-by-column basis. And that gives you better performance and better scalability. However, as you'll see in the second to last bullet point, the most common mechanism for retrieving a field out of a row using a record set is still maintained within the data reader. That is, you can still use the basically this accessor notation in order to look up a field by name. That will return the value as an object, which then you can use as an object or cast a particular type. It's not going to be as performant. It's going to be the same performance as you would get typically in an ADO-DB model, but the code will continue to work. The data reader also supports data binding, not on the CDs that you have, but on the CDs that you'll get as part of the Beta 1 release. That is, you will be able to bind controls to the results of the data reader, so the controls can directly read the data off that stream and close it without having to cache that data into a data set, a list, or some other object. This code example, again, written very similar to the code example that I had 2 years ago, shows how to retrieve data from a data reader. In the PDC bits that you have today, when you call execute, rather than returning a data reader, it takes a data reader as an out argument. That's actually being changed for Beta 1 to be more consistent with the model in ADO-DB today, where the execute will instead return a data reader. Once I have that data reader, my process for reading through it is very similar to how I'd read through a forward-only record set, except in order to emphasize the fact that this is a forward-only object, we use read instead of move next. So I'm going to loop through reading data out of this data reader, and for each row, I'm going to look up the author last name field of the data reader. So I'm not using the performant mechanism here. I'm using the model closest to ADO-DB. At this point, I'd like to introduce Tom Kaiser. Tom is going to give us a demo in Visual Studio of using an ADO connection command and data reader.
Thank you. My name's Tom Kaiser, and I am Mike's demo dolly for today. What we're going to do is we're going to go through a real simple scenario. We're actually going to do the first sample using Visual Basic, and we're going to show it in web form. What we're going to do is we're going to create an instance of a connection, of a command, and a data reader, and actually write the output from a query out to the web form. To do this, it's actually pretty simple. All I've got up right now, it's up. So what I have right now is just a simple, empty web form. And we're going to see an empty web form. We're going to drag some code over. They won't let me actually type because my typing is so poor. So we're going to drag it over. First thing we do is drag in the import statement for the SQL Server dataset command. Now this is very similar. If you wanted to use the ADO dataset command, you'd simply replace system.data.sql with system.data.ado. Next thing we're going to do is declare a couple of variables, and those variables will be our our command, our data reader, and our connection. I'm going to walk through these a little bit. The connection statement, this line right here, the middle line, you'll actually see it looks very similar. I did it a little differently than what Mike was talking about, where you did up an instance of the connection and then set the connection string, because I wanted to show in Visual Basic that you can actually use constructors to establish your objects. Here we're simply using constructor on the command object to set it up so that it actually instantiates a connection to the local SQL server on my laptop. The next line line down, the command, actually sets up the instance of the command that's going to be executed against the database. In this case, you can see all I'm doing is dimming my command as new SQL command. And the first part of the constructor is the SQL statement that I want to execute against the database. Now, Mike mentioned earlier that the command is very particular to whatever data store you're going against or whatever data command you're using. We're going against SQL Server, so it's relational, but it could be anything. I mean, it could be a non-relational database or an object-oriented database. It could be almost anything. The second parameter of the constructor is the connection that I created in the line previous. The third object that I'm creating is an instance of a data reader. This is the SQL data reader. We're going against SQL Server. And what I'll do is I'll use this to actually pull the data back from SQL Server and then write out to the screen. What we're going to do on here is actually drag a new item in Visual Basic down, which is the try, catch, finally block. For VB and for C#, basically the try, catch, finally block allows you to handle errors. The try is where you put the code you want to execute. If an exception occurs, it's structured exception handling. If an exception occurs, the catch statement is executed. And the finally statement is really neat because the finally statement is executed no matter where, or no matter what happens, no matter what the error is, the finally is always executed. So what we'll do is, in the try code, we'll actually put in there our connection open. So my connection, which I had created earlier, we're actually going to open the connection to the database. Through the connection object, you can do all sorts of things, like if you want to open a connection and hold it open for a period of time while you're doing transactions, you can actually do transactions off the command object, or the connection object. Next thing we're going to do is we take the command object that instantiated, and we actually execute. Mike stated earlier that in this version, for the PDC bits, we actually take a data reader as a parameter in and return it back, and we work with it. In C#, you actually need to preface this where it says my command.execute open parent out, OUT lowercase, space my reader, close parent. This executes command against the database and brings back a data reader into the variable my reader, which is then populated with the results. And the next part of this is a simple while loop. And as Mike said, we do the read because it's a forward-only cursor. It's a forward-only, read-only cursor. So while this returns read returns a Boolean, says true if there's more, we actually continue to loop. Now, I did both types of data access. The first one is what Mike said by the ordinal definition. So you see in here, it actually says myReader.getString. There are a ton of different accessors for the different data types, and this is the most efficient way of accessing data. And the 0 simply says we're going to retrieve column 0. The second way of doing this is the more ADO-centric way, which is the my reader and then the name of the column you want to return. You'll notice that this actually returns an object, and so we need to append a toString onto it to write it out. Now, the last part that I'm going to do, I'm actually not going to put an error handler in there, but it's real simple. It's just a matter of, actually I did this poorly, but so catch E, or my exception as EXEPTION. Okay? So in the finally block, what's really important to remember is you always want to close the connections and free up the data reader when you're done with it. And that's what I'm going to do in the finally block. What I'm going to do is actually go out and say, what's the state of my connection? And if that connection is open, I'm going to close the connection. And then the next thing I do, I check to see if the data reader is actually a variable, if it's an instantiated instance. And if it is, I'm going to set it equal to nothing. What this application is going to do, hopefully, is actually execute against the MSDE installed on my PC and write out a simple set of data from the Northwind customer database onto the web page. And it's working. It's slow. I mean, and there you have it. A nice little simple ADO plus application. Mike?
Great. As soon as we get our slides back. All right, so that was the connection and the command and the data reader. Now I want to talk about one of the new innovations, the data set. The data set we've alluded to a little bit earlier, but I want to touch on a couple very important points about the data set. First is that the data set is a relational view of the data. The data set can contain multiple tables with columns, rows, and constraints on those tables, and relations between the individual tables. Once it's set up in this manner, the user can navigate those relations between the tables in any manner they want. They don't have to set up some shape command ahead of time that defines a particular hierarchical view of the results. These data sets can be just created out of thin air. You can new a data set, you can add a table to the tables collection, populate it with columns and rows, specify constraints and relations between tables, and start putting data into it. The cache has no knowledge of where the data in it came from. It's simply a cache, a relational cache of data. Because it has no knowledge of where the data came from, it doesn't need to worry about anything like connections, commands, any of the source data got into it. That makes it a very good disconnected and remotable object. The fact that it has no knowledge of where the data comes from also means that you can have predictable behavior and performance characteristics. With the ADO rec set today, even though you have one model, one object, and a common way of working with that object may or may not support different behaviors and different functionalities depending on who has implemented the underlying row set providing support for that record set. Just as bad, even where functionality is supported, it may come with different performance characteristic or different side effects. If you're holding a cursor open on the server as you're scrolling around, making round trips each time you scroll forward or backwards, that's going to have much different semantics, much different scalability, much better performance, much different performance than if you're working over cache data. So by defining an explicit cache for the data, we're able to free you from that uncertainty when using this object. Similarly, we're able to customize how you work with and access this data in a manner more appropriate to an integration within your programming language. That is, we're able to provide things like array type indexing, where you can go to the third column of a particular table, the fifth row of a particular table, without having to worry about what's going on in the back end, scrolling you back and forth and up and down. This code sample is very different than any code sample that we had at TechEd 2 years ago, because 2 years ago we didn't have the data set. What this code example does in the first line is it news instance of a data set called pubs. This does come from a connection or a command or a database or any other data source. I've just created an instance of this data set out of thin air. Once that's created, I'm going to create a data table called inventory and add two columns to it, one called title ID, the second called quantity, both type int32. Once I've created that table and added those columns, I'm going to add the table to the data set, and then I'm going to insert a row of data into that table. It's all very simple and straightforward. Now I have an object that I can move around my application between different tiers without having to worry about where the data came from or what semantics may be. As I said before, the dataset command is the object that interfaces the dataset object with data source. In the old ADO model, there was sort of an internal piece of logic that knew how to take a row set and push it into a client-side cursor a disconnected record set and try to keep some information about how that row set was created so that if you made changes and tried to update those changes back to the data source, you could create commands in order to do that. All of that in ADODB was done as a black box. It worked fairly well if the back-end database exposed SQL commands on base tables for doing insert, updates, and deletes of the results from simple single table queries that you use to populate the record set. However, when we talked to our customers, we found that in most cases, customers didn't have direct access to base tables, and business logic didn't allow them simply to directly make changes to the base tables that they did have. Instead, inserts and updates were typically done through stored procedures. So one of the things that the dataset command does is it makes very explicit the synchronization between the dataset and the data source, including allowing you to specify exactly how updates are resolved to the data source, what commands are used, and what other actions may be taken in that resolution process. So the dataset command supports two methods: fill dataset and update dataset. The fill dataset command takes a dataset, that is the dataset that you want to populate. It executes the statement that you've specified on the dataset command and pushes the results into that dataset. Once you've done that again, the dataset has no knowledge of how that data got in there. In fact, the way the dataset command pushes data in the dataset is just like the user pushes data in the dataset that I showed you in that previous code example. The dataset has no special knowledge of any data source. That means that once the data is populated, I can take that dataset and move it wherever I want and do whatever I want with it. I can tear down the dataset command and reconstruct it at a later point when I want to actually take any changes made to that data set and propagate them back to the data source. The way I do that is I call update on the dataset command, and I pass it that data source, or that data set that has had the changes made to it. What the dataset command then does is it goes in again through public user methods on the dataset to find out what rows have changed, what columns have changed in those rows, and it uses insert, update, and delete commands that I've specified in order to propagate those changes back to the data set. The dataset command all provides mappings between the tables and columns of the data source and tables and columns within my data set. That allows me to have friendlier names within my data set. Because the data set has no knowledge of how the data in it was populated, you can use multiple different dataset commands to populate the same data set. So you can put multiple tables from the same database, from different instances of the same DBMS, or even different DBMSs. So given one data set, I can create my own tables that have my application data in them. I can push data in from SQL Server. I can push data in from Oracle. I can push data in from DB2. And I can take all of that data, remote it around the tiers of my application, modify and change it, and then at a later time, use the appropriate dataset commands in order to send updated data back to the appropriate data sources. And that's pretty cool. Here's a simple code example that shows how I use a dataset command. In this code example, I'm going to create a new instance of a dataset command, and I'm going to use a shortcut here. I'm going to pass in the select statement that I want the dataset command to use, as well as the connection that I want the dataset command to use. Then I'm going to call the fill dataset method, passing in the same dataset that I used in the previous example, specifying that I want it to take the results and put them in a table called authors within that data set. Because the dataset does not already have a table called authors, the dataset command will create that table and push the data from the select command into that table within the dataset. So it's that easy to populate my dataset with results from a query. At this point, I'm going to make some changes to the data in the dataset simply by going into the 0th table, which will be my authors table, the 0th row, which will be the first row of that table, and setting the state field to Washington. Once I've done that, I can commit the changes back to the data source simply by calling the update method on the dataset command, again passing the dataset from which I want the dataset command to get the changes, as well as the table within that dataset. So if I had multiple other tables within that dataset, as I did in this particular example, the dataset command would know which table to get the results from in order to propagate them back to the back end. A little bit about data binding. I said that the data reader in Beta 1 will be able to be the target of data binding for data-bound controls. In the PDC bits that you received this morning after Bill's presentation, you are able to bind to a data set, and that will continue to be true throughout release. There are cases when you really want to bind to a data set rather than just a data reader. There are cases where the data is already in memory. It may be application data that you've created on the fly. It's cases where it's data that you've wanted to cache for some reason, as session state, or even commonly requested information that you don't want to go to the database each time to get. Regardless, once the data is in the data set, you can bind to it either through a data view or a data set view. A data view allows you to apply filters and sorts to a data table within the data set and bind to that sorted, filtered set of data within the table. Simply binding to a table falls short of what we really want to be able to do. One of the powerful things about the data set is the fact that it can represent multiple tables and navigate through those tables using relations explicitly defined. So by defining a data set view and allowing you to bind to that data set view, you can bind a grid control to a set of tables and apply similar filters and sorts to that set of tables. Data binding can bind to a number of different things. The data reader, as we saw earlier, data tables and views, data sets and data set views, arrays, collections, and something called iList. And Tom is now going to give us a demo of using a dataset command, and doing data binding to that data set. Tom?
Great, thank you. So I'll just close this. And we're going to do another simple little app. The first one I did in VB. This one I'm going to do in C#. What we're going to do is we're going to build a data set, use the method of actually having the dataset command push table structure into the data set. So we're just going to use select statement. We're going to use that to populate it, and then we're going to bind to a grid. So I can get my fingers working, right? So to start out with, we simply go out and select a C# project, a Windows application, and then we'll start dragging some code over. One thing to remind everyone about, when you install the software off of the CD you got today, there's actually going to be a whole set of quick starts that are made available. You actually find them under the .NET frameworks. You can actually install the quick starts. Most of the code that you see here is actually out there as samples on there, and there's tons of additional samples out there. So the first thing we're going to do is drag a data grid over the form and just kind of make it a little bit pretty. Should have brought a mouse, not this eraser. So drag the grid. We're going to put a button out there, and on the button push, we're actually going to set it up to load the data set. So just like in VB, You actually just double-click on the control, and you're actually editing code. So this is going to look familiar. The first thing we do is drag out the using. Only difference there is in VB, it's an import statement. In C#, it's a using statement. Then we want to go down to the class declaration, which is right here. And we're going to put a instance of the dataset variable at the class level so we can access it in multiple places. And you notice what I'm doing here is simply instantiating a new instance of an empty dataset. As Mike said, there's two ways to actually populate a dataset. You can actually go through programmatically and add in tables and add columns to the tables, or you can allow the dataset to do it, or the dataset command to do it. So the next thing we do is we go back down to the on button click event. We add a couple more variables, and this should look familiar. We're going to instantiate a connection object, same way we did before. We're using SQL connection. And you notice this looks a lot like the old ADB connection string, but a little bit different. Since this dataset command only works against SQL Server, we don't actually have to worry about provider. There's a whole bunch more options documented in the help, but this is the basic syntax, connect locally. And I have a lot of security, SA, no password. The next one down is I'm going to instantiate and create two instances of dataset commands. The first dataset command is going to be my customer's dataset command. It will actually go out and do a select asterisk from the customer table in the Northwinds database. It'll push that into the dataset and create the customer's table. The second instance of the dataset command that I'm creating is going to go out and create, or go out and execute the select asterisk from the orders table. And then that's going to create the table inside the dataset and populate it. So the next part of this is now that I have my dataset commands, I can actually call the fill dataset methods on them and populate the dataset itself. And you see here it's actually pretty simple. What we do is you simply pass in the dataset that you want to populate, and in this case we're going to give it a table name that we want to call that table inside of the dataset itself. So for the first one, on the customer's dataset command, I'm going to populate the customer's table and call that table customers inside of the dataset. Same way for the line below it, we're actually going to call the orders dataset command and populate the orders table. Now the really hard part is actually data binding this. And I know a lot of you are probably thinking, gee, data binding, that's a really effective way to do things. But the data binding model that we've done in the .NET frameworks is actually very functional. You have a lot of power through the data view. You can bind, you can do complex binding, which we're doing here, where you're binding a whole table or a set of tables. Or you can do simple binding, where you can bind individual columns to text boxes or whatever. You can all bind now to list boxes and stuff like that. You can see here what we're doing, nice and simple. We're saying data grid 1, data grid that I put on the form, data source equals dataset.tables 0. In this case, we're doing a weakly typed, quote unquote, weakly typed access. You could go dataset.tables, quotes, customers, quotes, in the default view. Mike mentioned that there are data views, which we use for bindings. Every table inside of a dataset provides a default view, which gives you an easy way to bind to that dataset. So now, with any luck, this will run. And this is a WinForm app running under C# in the .NET framework. Maybe. No, it's still chugging. Okay. So now I'm going to go out and actually push the button. And what it's actually going to go through now is it's going to execute the two fill commands, which are going to bring the individual tables back from the database and push them into the dataset. If you notice, when I set up this grid, I didn't have to say anything about it. It actually went out through reflection, through the ability to look at the objects that the .NET framework provides. It went out through reflection and actually asked the dataset what information it had, what were the columns, what were their names, how do I display them. So this is the first one. If you notice, I loaded two tables into the dataset. Right now, I'm only showing one of them. Wouldn't it be really neat to be able to actually show both of them and drill down into it? We can do that. We have the technology. So all I'm going to do is add a single line, which is actually creating a relationship between the two tables in the data set. So I need to move it up. So what this is Mike was talking about how a data set is really a collection of tables. And each table, in our case, the customer table and the order table, can actually have relationships between them. So we go in through code here. Visual Studio or VisualStudio.net actually provides the ability to do this through designers. But so we actually establish a relationship between the two tables. So I'm saying in here, build me a relationship called orders. That's just the name of the relationship, and we'll see where that comes up later. My parent column is the customer ID column out of the customer's table, with my child column being the customer ID column in the orders table. So all I did was said, the customer's table is related to the orders table via the customer ID. And what this gives us is the ability to actually navigate that relationship and say, for customer X, give me all his orders. And have it return a set of orders that represent it. This is really neat because you can do things like, for each customer in the customers table, for each order for that customer, and do work with one. So now, with any luck, this will run. So this is the same app with one line difference. Yeah. It just didn't want to do it. We're always paranoid about things actually running. So now when I push the button, we do the load. We'll actually get that same data back, but we'll have an additional feature now. All I did was add that relationship, but the grid picked it up. This is a component we're actually shipping. This grid went out to the data set and said, okay, show me the table you have. Now that I'm binding against customer's table, give me all the relationships that exist in that table. So that he can go out and show us all the relationships. All the relationships that exist. Let me do another one. So in this case, remember we created the relationships with the name orders. And that's exactly what's showing up here. If there were more relationships in there, like to a address table or something, those relationships would also show up. So now if I click on orders, we've actually navigated that relationship and brought all the orders for that customer into the grid. So now I can actually navigate back, and you go back to it. And that's the ease of data binding and data. Thank you.
Thanks, Tom. I want to talk a little bit now about ADO and XML working together. The first area that you'll see XML creep into this ADO plus architecture is with the data set. The data set itself knows how to take the data within it and save it out as XML. And it knows how to take XML and read it in, recognize the structure of the XML data, and do what we call shredding, normalize the relational structure of that data into the data set itself. As well as loading and saving the data of the data set knows how to save its schema, that is, the tables, rows, columns, and even relationships and constraints defined within that data set as XSD schema. Similarly, you can take either XSD or XDR schema and load it in, and the data set will generate tables, rows, columns, relations, and constraints based on the definition of schema within that XSD or XDR file. Finally, you can generate schema in the data set by loading in XML when you don't have any schema defined in the data set. The data set will look at the structure of the XML data it's reading in and will infer schema based on the structure of that data. That is, where it sees things like repeating elements, it will assume that those are rows with the table. And nested repeating elements become related tables. But the data set exposes a normalized view of your XML data. That is, when you're looking at data through the data set, it's only exposing things that make sense or are meaningful in the relational world. So things like ordering of elements or white space, or even data that's not mapped to your relational view, are dropped by the data set. So loading XML data into the data set can be lossy. If you want to be able to get a relational view over a subset of your XML, you can do that by associating a data set with an XML data document. For those of you who weren't in Omri's presentation just prior to this, an XML data document is a W3C compliant DOM that knows how to store structured data in a data set. This gives you a number of different benefits over loading the data just into a data set. First of all, by loading the structured portion of the XML into the data set, we can conserve and optimize the memory required to store that data. Because it's easier to store structured, known, repeated data than it is to store just random nodes of data. By associating a data set with an XML data document, you can now bind to that subset of data that is mapped to that data set. So that binding we just saw Tom do, the complicated control binding and hierarchical binding and grid binding, all of that can work now over that subset of your XML document that you decide you want to expose relationally. This also allows you to simultaneously expose the same data either as relational data or as XML data. Finally, it allows you to use XML components such as XSLT and XPath over your relational data. And this example shows doing just that. What I'm doing in this code is I'm taking the data set that I created in the previous examples called pubs, and I'm creating a new XML data document associated with that data set. Once I've done that, I now have my data available either through the data set or through that XML document. Because the XML document is a W3C compliant DOM, every time I access an element within that XML tree, it has to create an object for that. So that if I revisit that same object, I will have object identity. However, creating a lot of objects can be expensive, particularly in a garbage collected environment. So the document navigator allows me to navigate through the structure of the XML document without creating objects for every node that I visit. So in particular, the data document navigator knows how to navigate this XML data document that has some of its data stored as a tree and its structured data stored in the data set, and can access that structured data in the data set without creating additional nodes. So I'm going to create a document navigator over my XML document, and then I can use the XPath query through the select method in order to select from the root node the authors whose state element is California. And for each of those authors, I'm going to return the author last name. So this is an XPath query that I'm able to execute over my relational data because I've associated that relational data with an XML data document. Once I've done that, I'm going to use methods on the XML navigator to move through those selected records, writing out the text of the particular nodes. And now Tom's going to give us a demo of doing this within Visual Studio.
Sure. So we're going to start out real simple. We're going to continue with the same application that we did the last one in. We're basically just going to add a button to the screen. soon as it reparses the form. So what we're going to do is we're going to add a new button. We're going to, in that button, we're actually going to execute an XPath query that goes through and looks for a specific identity inside of an element, and I'll walk through that. And it will return it, and then we'll display it as a message box. So it's actually really simple. Just add another button. Go into the event. Go out and drag my other code out. So to do this, to use the XML file, right now you need to do an include, or a using. And right now it's called system.newXML. Just prior to this, we were in the process of aggregating some of our libraries together. This will actually change to become system.xml. So just think of it that way. For the PDC, it will be system.newXML. Then we go down to our new button, button 2, and we drag over the code that will actually do the XPath query and get the document. So if we look through this code, on the first line, we're actually going to go out and build an instance of an XML data document based on the data set that we created earlier and that we populated. So as you see here, we simply pass the instance of the data set into the constructor. From that, we actually get our navigator, our navigator on top of the XML data document. With the data navigator, we're actually going to go out and execute the XPath query. I'm far from an expert in XPath. Mike is. But so really what we're saying here in the first part is do a select across this data navigator, across the XML portion, the XML data out of the data set, starting at the root node of customers, which is customers is our table, looking anywhere where the column, or in this case the element of country, equals Mexico. And then we want to return from there the company name. So we'll actually do, the next statement here actually moves to the first element that was returned from that query. And if there's more, you can keep moving to move to the next selected. So you can do a do while in effect here. We're only going to show the first one because there's only coming back. And then we're actually just going to do a message box. And we're actually going to show the HTML, or the XML rather, that was returned from that. So now, we'll run this again. Oops. There were build errors. There can't be build errors. Oh, sorry. I forgot to add the reference. So, to gain access to all these things, all the actual namespaces exist within assemblies or DLLs. So in this case, we actually have to go out and add a reference to the system.xml assembly. And that's as simple as just walking down to it, double-clicking on it, and saying, OK. And now, it should run. Good machine. So we're going to actually execute the load we did a minute ago so that we actually build the table, populate the relationship, populate the tables, and build the relationship. And then we're simply going to execute that code we just added, and a message box will pop up actually pulling that element out. This is actually really neat because if you look at the data set and its underpinnings being XML, the ability to do advanced queries across it using XPath, the ability to do all sorts of things, the ability to jump back and forth between a relational view of the data to a hierarchical or non-structured view is really an awesome idea. It's a really great capability. And that's mine.
Great. All right. Next, I want to talk about passing data to and from a web service. As I said, one of the benefits of the data set is that it is a disconnected, stateless object that can be persisted and loaded. And that makes it an ideal candidate for moving data across the different tiers of your entire application. There's something called web methods, which exists within a web service, and the web methods know how to take a data set as an argument and serialize that data set to XML and pass it as part of a SOAP payload between two pieces of code. And so Tom is going to show us using a web method that passes data as a data set.
Thank you. So in general sessions and sessions earlier today, there's been a lot of talk about web methods, or web services. It's a really awesome concept to be able to expose your business logic basically through an API on the internet or through a network. It's real simple to create a web service in either C# or VB. Quite honestly, it's just all you have to do is go out, choose whether you want to do Visual Basic or C#, and then pick web service and give it a name. I already have one up that... Oh. Can we get the slides back to the demo? Thank you. So I've already gone out and created one. This actually creates a web service. And what we'll look at is, you see a whole bunch of interesting little files. The .disco file, which actually provides a discovery mechanism, so you can go out and find the services that a website exposes. And then the ASPX form, which actually allows us to write code. So in here, this code will look very familiar. Really all we need to do, and as was explained earlier, okay, where is it? All we really need to do, I got the wrong one. So all we really need to do to actually build a web service is actually add an attribute to a method, a public method that says web method, and it actually exposes it across the internet, or exposes it externally. So what I'm going to do is actually close this sample, go out and build a client, a web or WinForms client in C# that will actually use a web method to return a data set from the web service and display it on the screen. So it's really as simple as doing exactly what we've done for the last several demos. Put data grid out there. Make it a little bit pretty. Oops. So put the data grid out there. See if this works. And then we'll put a button, just like we did before. And go into the code. And if you notice, I'm using a really neat little feature of Visual Studio. It's the ability to actually just drag code over to the toolbox and keep it there and make it available. It's a really neat, especially for demos. So what we're going to do now is we're actually going to go out and add the web reference to our project. So this goes out and it asks us where do we want to browse to. If I had an internet connection, I could actually browse to any site and that has a disco and expose it. So I'm just going to do it on the local host right now. And what will come up in a second is a listing of services that are available off of my machine. From there, we can actually explore in. That still worked. So we can come down to the list. It's because I hit it twice. But so we can come down, we can actually pick the service we want. I have a bunch of little services on mine. We'll drill into it, and we'll get more information on it. Okay? So what you normally see in the first one, too, is the actual XML, the SDL language that defines what this thing looks like. So here's the service that I have available. So I just add a reference, and a whole bunch of files will be added. And what's really neat about this is what we're doing is we're downloading the XML from a server somewhere, in this case my machine, bringing it down to the local PC, and then actually generating some files. There we go. I was beginning to get worried. So you can now see the web reference that I've added. The first one's to my local host. You see the web service one, which is the one I added. And you see a subservice1.cs file. When we bring down the XML that describes the web service, we actually generate a proxy. If you're working in a VB project, we'll actually generate a VB project or proxy. If you're working in C#, we'll generate a C#. This actually gives us the ability to programmatically access the web service. So now, come back out to the form, go back to the button. And what I'm going to do is simply drag out a small section of code. And in here what you see is I create an instance of a data set, I dim a variable of type data set and set it to null. Then I come out and create a new instance of a web service, the web service proxy that we just saw. And then what I do is I actually exposed on that web service a method called getCustomers. The getCustomers method actually just goes out, builds a data set, builds two data set commands, just like we saw earlier, executes them, populates the data set with customers and orders information, and it just says web method equals the data set that I just created, and the data set is streamed back across the web, across the wire as XML. When it gets back over here, what I'm actually going to do is push that return data set into my DS here, and then I'm going to bind it to that grid again. So we should see the exact same thing we saw in the last demo. The only interesting part about this is now we've exposed data and made it really easy for data and data sets to actually traverse the tiers of your application. So we're actually going out now, establishing an instance of the proxy, executing a command through HTTP, just an HTTP GET. That's going to go out and execute a method on the server, build the data set, and return it. Now I'm just spinning, since I haven't done anything with my IIS server on here, and IIS SQL server running on here, so it's all just spinning up right now. And there we go. You see the same functionality and everything. It's easily exposed across the web. Thanks.
Great. Thanks, Tom. The last thing that I want to talk about is something called strongly typed data sets. And I said earlier that one of the advantages of customizing a data object that we knew was built over a cache was that we could design it in such a way that it fit in better with your overall programming model. And strongly typed data sets is an ideal example of that. By being able to generate a strongly typed data set, you can work with your tables, rows, and columns as objects rather than as generic tables, rows, and columns. The relation and columns become properties of those tables. So in this example, I'm going to go through a strongly typed data set called myAuthor and access it in a strongly typed manner. So the same code I could use over the regular data set, but you would see me with, it would say things like for each table myAuthor in pubs.authors.tables, open square bracket, and so forth. Instead, there's a data set underlying this, but I can use it strongly typed. I can say for each myAuthor in pubs.authors.rows, what that's going to do is going to take the strongly typed authors table from the strongly typed pubs data set and return the rows as a strongly typed author object. And for each of those, I'm going to access the last name as a property of the myAuthor object. And similarly, I'm going to loop through the titles property of the myAuthor object as title objects. And for each of those titles, I'm going to print out the title property, which is a string property, which is the title of that object. So here's an example where I'm actually navigating hierarchical objects as objects with properties and methods on those objects, as opposed to having to try to step through tables, look up columns, reference relations, and so forth. So in summary, ADO Plus really is a natural evolution of classic ADO. It contains the same connection and command models, and it has data readers that model the forward-only record sets and data sets which provide the functionality of a cache disconnected client cursor. We've separated those two in order for each of them to be optimized both in terms of use and in terms of programming model. ADO Plus isn't just designed to work with XML, it is designed from the bottom up to be part of an XML.NET framework. And ADO Plus finally is closely integrated with that .NET framework. I want to point out just a couple of related sessions that you might be interested in attending. First one has already passed. That was Omri's ADO and XML overview, but that will be on the presentation on the CD. So for those of you who weren't able to be there, you can look it up on the CD. There's a using the XML framework, which Chris Levitt will be getting, and a follow-on to that, XML in Action, which William Adams will be giving. On Friday, I'll be giving the XML and Data in ASP Plus presentation, where we'll actually be building a ASP Plus website using various forms of ADO Plus and XML. Sean will be presenting also on Friday how the designers use data in XML in Visual Studio.net, and Brent Ingram will be presenting a Change 2000. And there are a couple other data talks, one SQL Server 2000 in XML, and the other on the MSL XML overview. That's about all the time we have. You guys are welcome to go get ready for SeaWorld. If anyone wants to stay around and ask questions, Tom and I will go ahead and take a couple questions.